Welcome to the video overview of the Audio-Based Accessibility Mode, AAM, for players with vision loss. This video presents 4 accessibility mechanics that utilize sound to provide feedback necessary for playing first-person video games. The AAM framework is designed to complement the standard game audio integration in video games. The goal of this project is to explore the potential of game audio beyond aesthetics and investigate its usefulness in providing crucial game information independently of the visual layer. This project aims to encourage audio designers to consider interactive sound as a tool for enhancing accessibility in modern video games. The proposed framework does not require significant changes to the traditional process of creating video games. The demo showcased in this video was developed using Unreal Engine 5 and the Metasounds audio engine. However, similar results can be achieved with other video engines such as Unity or Godot, as well as other audio middleware like Wise. AAM follows established principles of interactive audio design, with a strong emphasis on addressing the unique needs of players without sight, utilizing spatial audio information, and allowing for user customization. Each player is unique, especially when it comes to players with disabilities. AAM is based on extensive research into sonification, video game accessibility, and blind gaming. The design of AAM draws inspiration from the concepts of sensory substitution and environmental cognitive maps. The hypothesis is that sound-based mechanics, in the absence of sight, can provide enough information for a meaningful experience in modern mainstream video games. Now let's explore the demo. The AAM demo project includes full text-to-speech integration for all menus, submenus, buttons, and sliders.
Play. Audio glossary. Doors. Litbox. Medkit. Enemy detected. Audio beacon. Settings. Settings scroll down to choose.
On the settings page, players can adjust the volume of music, sound effects, ambience, and audio cues.
Audio and accessibility settings. Volume options go down to select. Music volume press enter to adjust. Sound effects volume press enter to adjust. Adjust with left or 90. Ambience volume press enter to adjust. Audio cues volume press enter to adjust.
Additionally, some elements of the accessibility mechanics are exposed in the menu, allowing players to customize them based on their preferences.
Access speech rate sonic scan area press enter to adjust. Adjust with left or right arrow key. 35 meters. 40 meters. 45 meters. Play. Choose level go down to select. Nav intercom sandbox mode. To demonstrate all 5 features, we will use a sandbox level. This level features a complete sound design, enemies, and a short mission narrative. The video will showcase how AAM can fit into an actual video game experience.
All right, soldier. Your objective is clear. Get into the research lab and retrieve data. Remember, the facility is most likely guarded, so you will have to neutralize all the enemies.
Copy that, Commander. I'll be back at the base in no time.
One more thing. We've parachuted a cache of weapons nearby. Locate and secure that arsenal before advancing. Proceed with caution. Stay sharp. Command base out.
Sonic Scan. Sonic Scan enables players to quickly scan the nearby area and locate interactable objects within the level. Different spatialized audio cues indicate the type of object. When multiple objects are within the Sonic Scan's range, the audio cues trigger based on their distance from the player. Less essential sounds, such as music or ambience, are temporarily filtered out. By double-tapping the Sonic Scan button, the player automatically faces the direction of the nearest interactable object.
Press E to interact.
A prototype laser gun? Nice one. Now time to get to work.
Wall Hit Notifier. Wall Hit Notifier is a passive audio feature that helps players identify the direction from which they hit a wall or obstacle. Distinct sound cues indicate impacts on the left, right, front, and back, providing players with a better understanding of their position relative to nearby obstacles. Sonic Depth. Sonic depth utilizes sonification to communicate the overall architectural layout of the gaming environment. Players hear a series of spatialized pings moving from right to left on a 180-degree angle. Different pitches correspond to distances of the level boundaries and larger obstacles, creating an audio map that guides players through the game. Higher pitches indicate nearby boundaries, while lower pitches signify distant ones. A short burst of brown noise signifies larger open spaces, giving players a general understanding of their surroundings. Additionally, players can enable the audio beacon sub-feature, which indicates the location of the game objective, such as a data shard from a research facility. The pinging rate of the audio beacon increases as the player gets closer to it. Similar to Sonic Scan, background audio is filtered out while using this feature, and double tapping allows the player to automatically face the direction of the level's objective. Sonic Depth is designed to complement Sonic Scan and Wall Hit Notifier, assisting players in creating mental maps of the game environment.
I guess I have a company.
I hate these double shifts. Feels like I've been standing here since the base was abandoned.
Yeah, tell me about it. I didn't sign up to babysit some rusty old gate. Got more action peeling potatoes back in the mess.
And the cold. It seeps into your bones like a specter, doesn't it?
Right. Like they couldn't install a single blasted heater out here. I bet it's quite warm in the research facility.
Have you heard any news about the project they're working on?
Something about energy or waves, I don't know. I stopped listening after they mentioned non-disclosure.
Sonic AIM. Sonic AIM utilizes two spatialized pinging sounds to assist players in aiming at targets. One ping represents the enemy's location at a constant pitch, while the other ping represents where the player is currently aiming.
They mentioned non-disclosure agreements.
Probably some top-secret weapon that'll end up...
The difference between these two values can be heard through the pitch and rate of the pings. Faster pinging indicates closer horizontal alignment between the player's crosshair and the target, while similar pitches indicate closer vertical alignment. The design behind Sonic AIM is to convey the offset of the player's aim from the nearest target. Once the player locks their aim on the target, an additional audio cue is triggered to reinforce that information.
Who the hell are you?
You will suffer great...
Sonic AIM also filters out less crucial audio to enhance focus and clarity. During this time, the player receives notifications about the directionality of the attack.
Enemy reloading weapon. Enemy reloading weapon.
Now let's see how all the features can be used to complete this level.
This must be the research facility. The data shard should be nearby.
How did you get here?
All enemies defeated.
That must be it.
Well done, soldier. Now return with the data shard back to the base. Transport is on its way.
AAM currently exists as a prototype demo. The features presented in this video are expected to undergo further adjustments. Testing with blind players is crucial to evaluating the real utility of the AAM mechanics. This testing phase will provide valuable insights into blind gaming and help promote game design practices that foster accessibility. Thank you for tuning in.